So thank you
Afternoon,
for
sir.
today's lecture. So this meeting we're going to discuss the topic on combined footings. No, so the first type of combined footing that we will discuss is the rectangular combined footing. So let me, if you have your notes, you can also open it to that particular page. No, so how to share. I've anymore. Siya. So makita na ba ang kuan? Akong kining screen. Okay, thank you. So kining kuan rectangular combined footing, halin mangutana ta ano sa man ni siya magamit nato no? So, for example, sa ka instance nga result ni siya rectangular combined is if we have a column which are spaced too close to each other. So, natay column dire no. Nya kung gamit ang isolated footing, ang ilang footing area mag-overlap na no. So, ang buhaton nato niya na, usahon na lang nato ang footing sa duha ka column. No? Ayun na. Lain sa nga instance pananglitan kuan ta dire kining we have a column which is close to the property line. So, gawas nila kung isolated ka, ang imong footing ingon ni ana, no? Yeah, samtang interior column footing nimo, naging ano ini. So, ang kasagaran buhaton ini na to counteract sa eccentricity dire sa exterior column footing, i-combine lang nato ang footing sa exterior ug interior column, no? So those are at least two situations. There, of course, there are other situations. I think that will be sufficient for now. Mga instances, no? Duha ka instances nga mogamit ang rectangular combined footing. Okay, so in the problem, design a rectangular combined footing to support the exterior column having a dimension 400 by 400 with a dead load of 530, live load 450, and the interior column having dimension 450 by 450 mm. So with dead load of 890 and live load 670. So footing cannot extend beyond the exterior column. So columns are spaced 4 meters apart. Then use Q allowable of 180 kPa, sub C prime 21 and FY 414 megapascals. So mo ni siya ang sitwasyon no. Ang kanidire ang atong exterior column footing dili siya pwede maka-extend beyond sa property line. Kani siya diri mo ni ang atong property line no. So di natin kabot ang footing dire so that will make the exterior column footing eccentric no. So to transmit the eccentric load ato siyang i-combine sa interior nga column footing. So, mo ni siya ang kuan, ang elevation view sa atong footing, no? So, this is the exterior column, this is the interior column, then this is the plan view. Now, ang basic nga principle nini, so I think I have stated it here, no? So, nag-ingon diri nga for uniform soil pressure, the location of the load resultant, that is including column moments, if any, must coincide with the centroid of the footing area. So, diri sa atong example, wala siya ay column moment, no? Just to emphasize, no? But the same principles will be applied if we have a column moment. So ato lang ning gi-simplify mga axial load ra nga atong gibutang diri sa kaning problem. So mo ning P1 P2 ang ilang resultant na diri and according to the principle aron ang atong pressure distribution underneath the footing will be uniform, then we just make the resultant column load pass through the centroid of the footing area. However, this requirement, no, aron atong ipaigo ang resultant column load sa centroid sa footing area would not be absolutely necessary, no. So kani siya ato lang ni siyang gi-apply nga condition because we want to produce a uniform soil pressure, no, underneath the footing. Of course, ang non-uniform, in case the resultant column load does not pass through the centroid of the footing area, then that will cause an uneven pressure distribution. Pareha sa axial plus bending problem, no? So, ang kuha na, there will be a consequent complexity, no, in the analysis kung uneven ang atong pressure distribution. So sa pagkakaroon kay introduction pa man ni siya, no, sa pag-design nato sa combined footing, so we will try to avoid that complexity first. So mao na nga ato ni siya ni proportion nga uniform ang atong pressure distribution. Siya, no? So do na ba question, no, regarding ining kuan, ining principle? Don't be surprised. A friend and classmate, Engineer Salera, is here. I think you know him, no? Okay, so naapay gusto mo join itong klase. So, atong i-admit. Sige, balik ta sa atong kuan. So, doon na ba question regarding sa kanang principle? So, aron ang pressure ilawom sa footing uniform, kinahanglan ang resultant column load must pass through the centroid of the footing area. However, that is not an absolute requirement in the design of the footing, no? Kung di gid kalikayan, pwede sad nga uneven ang atong pressure distribution. Pero medyo mas lesson siya sa pag-calculate nato, no, or pag-design nato kung dili uniform ang soil pressure. So any question regarding the principle? So di pa tayong padayon sa unahan. Na ba yung mga pangutana? Mingawan. Any question? None? Okay, so anyway. So there is a problem, no? Kaning spell out ng mga nato in detail, no, ang mga calculations, ang mga numero ato yung gi-calculate. So what I would like to focus in this discussion are the principles that we invoke in these calculations. So assuming that we have already proportioned the footing based on this principle, no, for uniform soil pressure, the location of the load resultant, that is including column moments, if any, must coincide with the centroid of the footing area. So assume that we already used that principle to obtain, no, the dimension of the footing. So ang atong buhaton ini ang sunod, no. Humana to mo-convert ang mga service load to factored load. We just multiply the load by their load factors, no. So kani diri sa atong solution nga gi-present, ang atong load factor nga gamit sa dead load is still 1.4, sa live load 1.7. At again, take note that in the more recent edition of the code, these load factors has already been changed, no. Ang dead load na to nga load factor is now 1.2. Live load nga load factor is now reduced to 1.6. So manini ato ning ma-compute ang factor nga column load, then we can compute the uniform upward pressure. So we just add the column load, then we divide it by the actual area of the footing. Then after that we convert, no, uniform upward pressure, which is still in kilopascal, to an equivalent linear pressure in kilonewton per meter along the length of the footing. So So pwede nga kaning 250.7 kPa i-multiply nato ni sa width sa footing, or pwede sad nga ang sum sa column load atong i-divide sa length sa footing, no? So that will give us the same result. So una atong gi-analyze diri ang longitudinal nga direction, no, sa gitason sa tong footing. So after the conversion sa pressure into equivalent linear pressure, then we can draw the beam diagram, no? So kanay mo ni siya ang gitawag na tong beam diagram or the load diagram. Ang footing atong gi-treat nga mura siya og beam, no? So diri sa ilawom na diri mag-akang upward nga pressure nga 732.7 kilonewton per meter. Diri sa ibabaw sa atong kining footing na diha mag-aksad ang atong column load, no? So kining mga column load diri ato siyang gi-reduce or gi-convert nato sad siya ngadto sa equivalent nga force per linear meter. So to do that, we just divide the column load by the column dimension, no? So for example, 1507 divided by 0.4, you will get 3768 kilonewton per meter. Ya kaning 2385 kN, i-divide nimo ning 0.45 to obtain 5,300 kilonewton per meter. So once we have this beam diagram, then we can draw the shear and bending moment diagram, no, for the footing in the longitudinal direction. So regarding the construction of the shear and bending moment diagram, this is already a lesson which I've learned in the previous subjects, no, starting sa strength of materials, theory 1, theory 2. So again, I don't want to discuss this in detail, no, so because I would assume that you already know how to draw shear and bending moment diagrams. So muna siyang load diagram. Then from the load diagram, we have here the shear diagram. Then after you construct the shear diagram, you can also draw the bending moment diagram. Okay? So doon na ba ipangutana? Nini nga step sa atong calculation? Kaya na, no? Now, kuha na to, pag-determine na to sa mga shear ordinates, pwede ta mo gamit sa shear and moment equations, or pwede sad mo gamit ta nitong relations between load, shear, and moment, no? So regarding in this solution, I use the relation between load, shear, and moment. That the change in shear is equal to the area of the load, and the change in moment is equal to the area of the shear. But as you will realize later, no? So, for example, in the next type of footing that we will analyze, katong trapezoidal combined footing, it will be more tedious to compute the area. So what we did or what we will do, no, for trapezoidal combined footing is to use the shear and bending moment equations. So whether mugamit ka shear and moment equation or mugamit ka sa relation between load, shear, and moment, it will actually depend, no, on sa mas convenient in a particular case, no. So in the case of rectangular combined, masayon siya gamiton ang ining area or relation, no, between load, shear, and moment. But in the case of trapezoidal combined footing, I think it is more convenient, no, and more direct to use the shear and moment equations. But those are two alternative mga solutions. So by pangutana na ini nga portion sa atong solution. Now a note here, no, at the bottom, I have written here the last moment ordinate should be 0. So okay, I am referring to this point here. So mao ginanda na siya, theoretically it should be 0. But if you calculate that, no, and even in this presentation, makita nato nga ang final nga moment ordinate is not 0, natay murag tawag na natong error or wa mabalanse ba, no? We have a negative 19.08 kilonewton meter. So the reason for that being that we have an equal load factors for dead load and live load. So kung kuan pa sila, equal pa ang load factor sa dead load ug live load, then the solution, no, when we convert from service load to factored load will be consistent. However, since the load factor for dead and live are not equal, no, pag convert na to gikan sa service load paingon sa factored load, so doon na nay kining discrepancy nga ma-introduce, no. But I have noted here that the error is usually small and may be neglected. Now, usa ka ko ano, panalitan sa surveying, di ba? Magkuan mo close traverse, nga di mag ini gikan sa field data, imo nang i-plot, no? Di ba ginasiya mo sirado na amo ginay error, di ba? So unsa man inyong gigamit niadto, inyong gi-balance ang traverse, no? Doon naman to yung mga lain paagi sa pag-balance sa traverse. You have the compass rule or the transit rule. So a similar approach can be applied here, no? Atay error dire, then you balance it, you distribute the error to the previously computed ng mga moment ordinates. Pwede sa din na, no? If you want to make it more refined, no? Pero sa ako nang giingon dire, kaning final nga error kasagaran gamay, pwede ra gyud na siya nato i-neglect, no? Without introducing an appreciable kining difference, no, in the final result, for example sa thickness sa footing or sa amount sa steel reinforcement. So remember nga sa structural design, this is not an exact science here, no. So ang importante, we maintain a reasonable degree of precision in our answer, no. So dili gyud kinahanglan nga 0-0 gyud, di ba? So do na ba question regarding ini nga part? Pero magway tawas balay. Oh, kumusta mo diha? Naapa mo?
Sir.
Ba?
Yes, sir. No question so far.
No question, very good. Pero basig na ba ya? Kay ikog pangutana gyud. Eh kung man tuyo nga ato ning gi-discuss. Now, nga rita sa step 4, nya sa step 4 we compute the depth required for beam shear. Now, kung magtanaw, balik ta diri sa atong shear diagram. So, ang critical section for beam shear, of course, at the distance from the face of the column. So, kung ato nang i-relate diri, di man na nato, kani siya nga region, muna siya ang sa column nga region, no? So, kana siya, muna siya sa column nga region, kani siya, muna siya sa interior column nga region. So atong ipang badlisan asa tong the distance from the face of the column. So on the side of the kaning exterior column, mo ni siyang the distance niya sa interior column, no? So kanisa the distance gikan sa face sa column, sa pikas nga face niya nasa the distance dire. So mo ni siya mga critical section for beam shear. Now, I think it is obvious, no, nga ang mas dako nga value kini siya diring duol sa interior column footing because you have here a higher shear ordinate, no, 1405.28 at the face of the column. Pero dili na siya mo design shear nato, no, timan nato nga beam shear ganay always the distance from the face of the column. So mo na atong gi-calculate dire, no, pila may shear force. So kani nga shear ordinate then minus the upward pressure times D, because that is the amount by which the shear ordinate will reduce, no? So kung dire, then shear capacity, so Phi16 square root F sub C prime BD, so equate na to ng V o Phi BC to obtain D of 0.534. So muna siya sa beam shear calculation. Now for punching shear, so punching shear of course at D over 2 distance from the face of the column. So kana siya diha, no? And that would be true both for the interior and exterior column, no? So sa exterior column kanisa dang iyang critical section for beam shear, no? D over 2 distance. So pag compute sa shear force dire, downward column load, then minus the resultant upward pressure acting within the tributary area for shear. So mao na siya, no? So sa kuan atay di nga mo-compute for punching shear at exterior, nasa kay di nga mo-compute for punching shear at interior. So ang mo governa na ang pinaka no nga requirement. So for beam shear 0.534, for punching 0.484 at interior column 0.461. So ang mo govern ini is kaning 0.534 no. So kana 0.534 itong i-round off so we'll use 550 mm. So okay na. So after we have the thickness of the footing, the next step will be to compute the steel reinforcement. Now, if you look at the bending moment diagram, kita na to nga niining region, no? Gikan dire paingon dire, the bending moment is negative. So that means the tension is at the top, and that is where we place our steel reinforcement. Nya gikan ini nga point paingon dire sa end sa footing, the bending moment is positive, and therefore tension is at the bottom, and we place the steel reinforcement at the bottom. So to calculate the amount of steel, na naman kay maximum moment dire. So this is a case of given the design moment, you have the width and the effective depth, then you can compute the amount of steel reinforcement using the formulas you have learned in reinforced concrete design, no? And this has already been applied several times already, no? Even in the previous types of footing atong discuss na, no? So no need to go into that in detail for now. And for positive steel reinforcement, so mo to akong giingon nga kani diri nga region positive man ang atong bending moment, but the critical section for bending here, although the maximum bending moment is 315, and that of course directly under the column, no? Pero it's very stiff at the region directly under the column. Ang critical section sa bending will occur at the face of the column. Kana siya, no? So kanay diri mo ni siyang critical section. So to pang atong design moment is not 315 but rather 269.2. Okay? So muna atong gigamit diri. And again, if you have the moment, you have the cross-sectional dimension, B and D, then you can compute the required steel reinforcement. Now for the short direction steel, so meaning the steel, may kanisya diri, no? Kani ato na compute, these are long direction steel. Now by the way, kabantay siguro mo na ini, kini diri mo ni siyang steel nga required for negative moment, no? But we extend some of those steel reinforcement throughout the entire length of the footing. So the text by Bowles recommends extend at least 1/3 of the negative steel through full length of the footing. Mao sa diri ang requirement sa positive moment kanira diri nga region, no? But we extend part of that throughout the entire length of the footing. And this will also serve as chairs for the short direction steel, no? Aron magkuhan siya kanang form sila og grid, no? So ngarita sa short direction steel, so ang steel nga atong ibutang niini nga direction. No? So pila man. So ang gi-recommend ni Bowles nga approach nini because this is actually an indeterminate nga problem, no? So the textbook in foundation design recommends an approximate solution which is also conservative, no? Now with the present technology, tay mga software nga mo handle og finite element analysis, you can do a finite element modeling, no, for the footing and obtain more economical results, no? Kay kani siyang mga traditional nga mga approach sa footing design, which I think has not changed over the years, no? Sa mga bisan sa mga bag-ong nga mga textbook, mao gihapon ni siya ang iyang gi-recommend nga mga hand written nga calculation, no? So mo ni siya panahon pa namon Engineer Tornes, panahon pa namon Engineer Salera, no? So it's the same, no? So this is something kuan, di ba? You bisan pa sa naanay mga finite element modeling tools, no? But we still go back, no, to the traditional method of doing things. And this will also serve as a check for computer-aided nga mga solution, no? Kaya kanang computer-aided solution, kaya manual checking niya na, kuan, no? Kung nagditaw sa computer parlance, garbage in, garbage out. Kung doon na kay sipyat sa imong modeling, of course, nasa naisip sayop na sa iyang mga output, no? But if you have a manual checking, then you can verify, no, the correctness of the output sa mas sophisticated nga kining modeling. Okay? So it is still important to learn this traditional method sa design. Of course, di man sa tanan na to nga maka-afford na ng mga complicated or sophisticated kayong mga software, and this will come in handy. Ang kinahanglan rin ni natay Excel nga kung ano. So you can formulate Excel-based nga mga software. So bisan sa mga ako ano, makita na ko sa mga structural design firm, even sa mga dagkong structural design firm dito sa Manila. So sa ilang footing design, kasagaran naagihapon sila ay gigamit ng mga Excel-based nga mga solution. So they don't really they don't really rely on full automated nga design. Naagihapon sila mga Excel-based calculation, which follows kani siyang mga procedure. Okay? So ang ideya ra niini kung mag-design ka sa transverse direction steel, imurang atorang i-assume no nga ang column load, exterior column load will be supported only over this small area, no? But of course we know that the load in this column will be distributed over a wider area, no? But with decreasing amount of pressure, no? Mas dako yung pressure katong portion nga duol sa column, di ba? So I think that is we can understand that intuitively, no? Kung asa tong column dapit na butang in relation sa footing, mas dako og stress dito, no? Kaysa katong mga portion nga medyo layo na. So mo na siya ay concept dire, no? Nga natay tawag na to tributary area, no? Bandwidth niya is A plus 0.75D. Now, some textbook, for example, sa textbook ni Winter, ang iyang gi-recommend is 0.5D. Ang isa kang goals, 0.75D. Itong nasa ilain ng foundation design ng libro, I already forgot the author. May-recommend siya og 1D. No? So in this approximate or simplistic na mga method, dili sad uniform, no, ang mga textbook. So mao gina, no, di ta maka-expect og uniformity gyud sa mga butang wa pa kayo siguro, di ba? So mo ni siya ang approach nato sa interior nga footing to determine the steel reinforcement diha, no? So ato rang i-consider nga kini siya nga column is supported only within this tributary width. So the column load divided by this area, no, nga reduced nga area, will give you a somewhat large amount of pressure. And you treat this as though it were an isolated, no, isolated condition during a kanira nga portion. So critical section for bending will be at the face of the column, no? So ingon na yan. So i-design na to ang transverse direction steel so within this bandwidth and within this bandwidth here. Then for the remaining zones, we just supply minimum steel reinforcement. So ang atong remaining zone, kani siya diri nga region, I will highlight that with color green. Kani nga region diri, o posible na gamay nga may bilin diri sa kanindiri nga region, no? Okay. So kano siya mo na siya ay kuan. So as you can see, there is no uh, really difficult nga mga principles or concepts nga atong gi-apply except those we have already I think learned, no? Ang bag-o lang siguro nini kaning pag-compute sa transverse direction steel where we consider a bandwidth, no? Bandwidth. So dowel calculation, this would be optional, no? If we embed all the column rebars into the footing, so we don't have to compute these dowel requirements. And of course, we have checking for the development land. Then step 14, we check the weight of the footing because initially we assume it, no? So karon nga na tay size sa footing, and we can now compute the actual weight of the footing. Then just compare it to the assumed weight. So if the well, usually, no, in my experience sa calculation, it does not vary significantly, no? Kung assume tag 10 to 12% of the combined column load, then it will usually be close, no, to the actual weight. So ang final nga output na to is of course the details. So all the results of our calculation, we have to translate that into design drawings, no? So ang pabalik ko na to ang guide sa paghimo og drawing unsa atong una-una unsa may gikinahanglan nga information, no? Aron kining atong footing ma-construct siya as according to our intention. Saya unsay size sa rebar, asa ibutang, pila ka buok, pila spacing, unsay gidakon sa atong footing, no? So those information are needed sa construction site, no? Pag-implement nila. So kinahanglan we supply them with all the necessary information without any ambiguity, no? Nang klaro, dili siya ingon nga ma-misinterpret, no? So we have to make our drawings clear so that it contains all the necessary information without too much nga redundancy, no? Kaya di sad mayong daghan kayo overload kay information, balik-balik na, no? So, kuan sufficient amount of information. And you can also study sa kuan, no, kanang mga structural design drawings, mga structural engineer, no? And you learn from them, no, how they present the structural details sa mga footing, no? You can also read from textbooks. Ay human sa mga practice problem at the end, no, naamag na siya ay presentation nila sa structural detail, no? So ang gikan dito makaton ta, no, unsa day sa mga pamaagi sa pag ining present sa mga drawings, no, ining mga footing. So there is no hard rule, no, o mao gini siya appeal na to. So it takes a lot of common sense and also ining things that we have learned, no, from other people who have done the same thing. Okay, so I think that's all for this meeting. Now, next week, I've heard that it is kwan,
TC days.
OTC days, no? So, Camille, are you still the kwan?
Yes, kami boss.
Oh, Camille, are you still the vice pres na ka? Oh. Oh, sige, kaya nangingod na lang vice pres ko, sir, no? Oh, ayan ang nalang kay murag kanang mayong tag nalang murag mo tag naminos ang atong kuan. Pero kanang vice president, that is a very kuan, no? Important role and dignified nga role, no, sa inyong batch, no? Okay, so unsa may kuan gani? Next week will be days. So in your other subjects, do you have classes or So kung na siguro mawala sa natong buhaton, no? Then we'll just catch up after sa kuan next week. I hope that we can recover sa mga kuan lost time, no? So di lang sa tamang klase next week. Okay? So when we week after next week, we will again meet face to face, and it's the time you have to submit sa katong problem set number 3 and 4, I think, no? Okay, nahuman naman ninyo ang 1 ug 2. So ang 3 ug 4 na sad. Katong dis murag ingon na siguro gyud. Balik na nato.
Excuse me.
Oh, oh mo. Oh, mo gyapon. So Neil, unsa may imo Neil? Neil Mac Neil Lau, you want to say something?
Sir, pwede mo clarify something about the kwan ganina, lesson ganina?
Oh, unsa man? Asa ikaw?
Ang unta sir kay sa katong ang positive moment nga gigamit para sa pag-design sa beam kay 269.2 ang gigamit sir per dili siya ang maximum nga positive moment. Is it because sir
Oh.
tungod naa siya sa murag overhanging part kunuhay sa footing niya ang katong maximum positive moment
Ano din itong
kay
column, no?
natunog siya sa column?
Okay, to answer your question, am I still sharing my screen? Naka-share screen pa ba ko?
Dili na sir, wala na sir.
Hindi na. Okay, I will share
Wala na,
again
sir.
my screen.
Yes. Scroll. Yes.
Swerte sa nilay ba, no? Swerte kayo, no?
Okay, so clean. So mo ni siya kay kani diri nga portion kuan mo guni siya natungod siya sa column, no? And of course the footing will not break directly under the column. Ang critical section nato is at the face of the column. Critical section for bending, no? It's at the face of the column. So dili katong maximum ordinate kundi katong moment ordinate at the face of the column. Di ba? So mo na siya reason. So are you satisfied?
Yeah, yes sir. Thank you sir.
Okay, sige. So what else?
Ay, sir. Good afternoon, sir. So,
Okay.
clarify lang, sir, sa katong answer ni mo kang Neil, sir. Kay if ang rectangular footing kay extend pagid sa other side, sir ba? If nasa negative sa kwan sa other side, sir, kay ang katupong critical section or sad ana, sir, I consider.
May
Ay, positive day, sir, sorry.
Oh, pwede. Mo mo sa. Oh.
Okay. Thank you, sir.
Okay. Will you excuse me for a minute? Nakapabay mga questions? Sorry kayo ha, kay si Indil Salera ni sorry mga diri sa office niya ni palakaw naman siya mo tong ako sang gikuyugan dito sa gawas. So nakapabay mga questions na to? Okay na lang. O sige.
So far from me, sir.
Sige, kayo mo niya.
So far din,
Thank you, sir.
Sige, kayo.